A quadratic equation must include an x squared term, but it doesn't have to include a linear term or even a constant. In this video, we'll look at simple quadratic equations that consist of an x squared term and at most one other term. Let's start with an example. This rectangle has an area of 50. What are the side lengths of the rectangle? For any area A, what are the side lengths of a rectangle of this shape? This is a rectangle whose length is twice that of the width. The area of this rectangle is the product of the two linear terms. We end up with 2x squared equals 50. This is a two-step equation. First, we divide both sides by 2 and find the square root of the quotient. Let's step through the solution. We first divide both sides by 2, as shown here, and we're left with x squared equals 25. Take the square root of both sides, and you have x equals the square root of 25, which simplifies to x equals 5. Going back to the rectangle, we can now find the values for the length and width. The width is 5, which means that the length is 10. Finally, we're asked to generalize this solution to any rectangle of area A. Going back to the area equation, we get 2x times x equals a, which gives us 2x squared equals a. From this point, the solution is similar to the one shown earlier. First, divide by 2, then take the square root of the quotient. We get x equals the square root of the quantity a over 2, which happens to be the width of the rectangle. The length is twice this value. Let's look at another example. This triangle has an area of 64. What are the base and height lengths of the triangle? For any area A, what are the base and height lengths of a triangle of this shape? This problem is similar to the previous example, but now with the area of a triangle. The formula for the area of a triangle is shown here. Area is 1/2 the base of the triangle, b, times the height of the triangle, h. We know that the area of this triangle is 64, so we end up with this equation. Also, even though we don't have numerical values for the base and height of the triangle, we do have variable expressions. Let's plug those values into the area formula. We end up with x squared equals 64. Take the square root of both sides, and we end up with x equals 8, which is the value for the base. This means that the value for the height is twice this, or 16. Finally, we generalize this solution for any area A. We end up with the equation x squared equals a. The solution is x equals the square root of a, which is also the length of the base. The height is twice this value. Let's look at a final example. A ball rolls off a 4-foot table, and the function shown below models the vertical height in feet over time in seconds. H equals -16t squared plus 4. How long does it take for the ball to hit the ground? This diagram shows what happens from time t equals 0 to when the ball hits the ground. At the beginning, the ball is 4 feet above the floor. After a certain amount of time, the ball hits the floor. At this point, the altitude of the ball is 0, which results in this quadratic equation. -16t squared plus 4 equals 0. Let's solve for t. We can simplify this equation by dividing both sides by -4, as shown here. We're left with this equation. 4t squared minus 1 equals 0. Add 1 to each side of the equation to get this equation. Divide by 4 on each side of the equation and then take the square root. We're left with t equals 1/2. So the ball will roll off the table and will take 1/2 a second before it hits the ground.